Hello, this is Roshni Venugopal, UR 14 CS 121, and this is my cryptography assignment number 2. So we'll be handling security attacks and solutions. So what is security attack? It is any action that compromises the security of information that is being shared by one organization to another organization. So basically there are three types of security: information, network and computer security. So whenever these are being compromised, that is known as security attack. One of the these are the security attacks that are posed on the information that is being sent. So this is the normal flow of this information from the source to destination, but when it gets interrupted in midway, that is known as interruption. When the message that is being sent is intercepted by another person or a third party, it is known as interception. The third kind of security attack is modification. That is, the information is taken by a third party, it is modified and then sent back to the destination. And the fourth kind of is fabrication. So an intruder or a third party will act as if he is the source, and it will send information to the destination. Now to conquer these security attacks, we have one of the method is to authenticate the message that is being sent. So using MAC protocol we can do that, but MAC provides only authentication of the message and there is no confidentiality. So to overcome that, HMAC was introduced. Now MAC also does not provide digital signature because both the sender and the receiver share the same key. So HMAC is a better protocol. These are the objectives of HMAC. Now in MAC protocols, the original message was padded with extra bits to divide it into equal number of blocks, but in HMAC this is without modification. So there is no modification of the original message and the originality is preserved. And also the use and handling of keys is very simple. So let's see how HMAC works. This is the original message, that is Y0 to YL minus 1, and the message is divided into equal number of blocks of B number of bits each. Now the original message is appended with S1, that is the selection bit, and S1 is computed using the cryptanalytic factor K plus and IPAD. Now these both values, K plus and IPAD, are originally IPAD is originally 36 hexadecimal value, and K plus is may or may not be B number of bits. If it is not, then on the left hand side zeros are appended to it. So these both values are XORed and it is stored as the selection bit. So this is the overall operation of MAC, and now here we will be concentrating in the first part of the section, that is K plus XOR IPAD, that is hashed. So in here the message, one of the message blocks is taken and it is hashed with an initialization vector that is of n number of bits, and since it is n number of bits, the output will also be n number of bits. But to convert it into B number of bits, that is the original number of bits that is required, it will be padded and the answer will be stored for the next step. So over here we are done with basically this part of the section. So in the second part, what we do is again the cryptanalytic factor K plus value is taken and it is XORed with the OPAD value. After XORing, there will be B number of bits that will be stored in appended with the initial block, and this block is the output of the first part. Now that block is taken and it is hashed with the initialization vector, again the same initialization vector of n bits, and the value, the answer of HMAC is obtained. And also over here we can see that K plus XOR OPAD, the second step, is appended with this first step, that is K plus XOR IPAD with the message and it is hashed finally to get the HMAC value. This is HMAC operation. Thank you.